So I mentioned deductive logic, and there's a number of different ways you can go for deductive logic. And by the way, a prime example of deductive logic, mathematics. Mathematics is a great example of deductive logic. Okay, but for more broadly, um, we can talk about mathematical logic. We could talk about categorical syllogisms from Aristotle. There's a number of ways you can go. Probability. Sorry, not probability. Modal logic. We could talk about first order predicate. There's lots of ways we could start talking about this, and that's fine. I'm not saying any one of these are good or bad, but they usually require. They can get pretty complicated. So I'm trying to give a user-friendly version of deductive logic. And for this, I like to start with truth relations. Right now, truth relations, broadly speaking, all the truth relation is that the truth value of one proposition affects the truth value of another. Right? And for this, I'm dealing just dealing with a dyadic truth relationship as just two propositions. We could have triadic truth relations, I suppose, right? Where the truth value of one proposition affects two others. Okay, we could do that, but let's leave that aside just for a second. Maybe even like a singular. Well, that gets a little weird, trying to talk about truth relationship with just one proposition. Let's ignore that too. Right? So we're just dealing with dyadic truth relationships. We got four basic truth relations: sufficient, necessary, contrary, and subcontrary. Now, sufficient means that the truth value of one affects the truth of the first proposition, means that the second is true, or true makes true. So, for example, I'm in a botanical garden, right? So here we got trees. Now, if an organism is a tree, then that organism is a plant. Right? An organism being a tree is sufficient for an organism being a plant. Right? That's sufficiency. Necessity is false makes false. Right? So if it's not a plant, it's not a tree. So this is maybe a little clue right away. If the first proposition is sufficient for a second, then the second is necessary for the first. Contrary means true makes false. Right? So if an organism is a plant, then the organism is not an animal. Getting our little biology, our second grade biology lesson today. Right? So contrary, right? An organism being a plant is contrary to an organism being an animal. All right. Then there's subcontrary, which is false makes true. Right? So just backing up a little bit, sufficiency, true makes true. Necessity, false makes false. Contrary, true makes false. Subcontrary, false makes true. Okay, and few little quirks in here. With contrary, if one proposition is contrary to a second, the second is also contrary to the first. If one proposition is subcontrary to a second, the second is also subcontrary to the first. So contrary and subcontrary are symmetrical. They go both directions. Right? Sufficiency and necessity are not so much the case. Right? They can be, right? It might be the case that if one proposition is sufficient for the second is also sufficient for the first, but that's kind of relatively rare considering the sheer number of propositions, right? So contrary and subcontrary, they are symmetrical. The relationship is symmetrical. Sufficiency and necessity, not so much. Okay, and also another little quirk, right? With sufficiency, if the first proposition is sufficient for the second is necessary for the first. Okay, that's true. But it doesn't work that way with contrary and subcontrary. If one proposition is a first proposition is contrary to the second, that doesn't mean the second is subcontrary to the first. It doesn't work out that way. All right, so these are the four basic truth relationships, and this is the foundation for understanding deductive logic.